panel of the day, titled The Next Generation of AI, will be moderated by PJ Makish, Vice President for Strategy at SCSP. Please welcome our speakers, David Stout, co-founder and CEO of WebAI, Myra Raghu, co-founder and CEO of Samaya AI, and Mikel Rodriguez, fellow at MITRE.
Good afternoon, ladies and gentlemen. Thank you so much for making time to be with us. This panel is really, we take a step back to 1956 when the phrase artificial intelligence was first spoken by a mathematician at Dartmouth who said that the processes of the human mind could probably be mimicked by a computer program. And here we are almost 70 years later with three of our favorite minds in AI to really think about where is it going and what does it really mean, what is the difference between human thought and machine thought from now and forever. So please welcome my panel. So just to get to know them, if we could just go down the row and please, you guys, share a story with the audience about sometime when artificial intelligence rocked you. You know, when did the intelligence of an AI system first impose itself on you? Mikel, start with you. You know, you were doing AI at MIT before you were at Jan LeCun's lab in 2011, doing a lot of work in computer vision, publishing a lot there. You had your hand on some of the best confidential systems that we could work on. You know, you went to DeepMind, London, back from there. When did it hit you? And tell us some stories.
Yeah. Well, first of all, fantastic to be here. I think the latest time it really hit me, and I had kind of the goosebumps moment, was when I was witnessing an AI system that solved the problem that had more kind of pathways and solutions than actual atoms in the universe, in the observable universe. And you see, just a kind of a quick background, since I was a kid, I was always kind of driven by this question of like, how do minds solve problems? And that kind of question drove me to working at Google DeepMind, where we had a whole bunch of scientists of different backgrounds coming together to try to understand and build intelligence. And I'll never forget, it was just some afternoon, and one of my colleagues stopped by and wanted to demo a prototype that they had of a system that was doing something called protein folding. And he kind of gave me the primer and said that proteins, their structure is really their job. So like kind of structure drives function, and function kind of potentially drive medicine. Right. And this was something that for many years, decades, was something going from this kind of protein kind of a sequence to structure would take years, a lot of effort and luck. And there I watched how they loaded up the sequence, kind of left-hand side of the screen, and then the right-hand side of the screen kind of materialized suddenly this beautiful 3D structure, almost like these proteins were falling into shape, almost as if they were waiting to do that. And it kind of really dawned on me, and I had this kind of goosebump moment of like, we're kind of at this cusp of potentially being able to do science at kind of digital speeds, and this kind of shrinking between curiosity and consequence kind of becoming a potential. So that was a real moment that will stick with me, kind of was recent.
So good. I remember the one that hit you too in 2011, like when you were actually in the lab and you could realize computer vision was going to happen and someday Teslas would drive themselves. It's really.
I'll never forget that one either. It's been, just like AI, we've had heights of excitement and kind of troughs of despair. Each of those heights have had some goosebump moment, and yeah, you're right. That was another one.
So
computer vision finally worked.
So cool.
Yep.
Myra, you've devoted your life to this. You're a PhD in Cornell. You Google Brain. So for those who are familiar with how Google operates, they had a shop devoted to AI called Google Brain. Myra was there from 2015 to 2022, 7 years. When that happened, there was a paper called Chain of Thought Reasoning in 22 that was at Google Brain. They kind of finally felt that they were able to have a family of algorithms that could reflect how the human mind reasons. And then you set out to start your own company. You've been doing this. When did it hit you? Like, tell us the story of when it really hit you.
Wow. Okay. So I think there have been a couple of moments when it really hit. So I started doing research in neural networks, which is like the underpinning technology for large language models, which is the underpinning technology for, ChatGPT and all of these AI experiences that we are so familiar with today and have been taking the world by storm. And so around 2012, 2013 time, was when we were first starting to see these breakthroughs in computer vision. I wasn't directly following the field, so much then, but there was a time in 2014 and where I was attending the Neural Information Processing Systems Conference, which is a big AI conference. It was 2,000 people back then. I felt like it was the biggest conference I went to. And, 8 years later, it was 20,000 people. So it really scaled 10x in the time. And somebody was showing their research paper of a neural network learning, and they were probing each neuron by neuron, and they were actually interpreting what that neuron was learning to represent about the world. So they were probing in and they were like, oh, well, this neuron has learned to detect faces, and then they would show the neural network a picture of a face and you'd see it light up, and they'd say, oh, this neuron has learned to detect animals, and they might show a picture of a lion and then it lights up. And until that point, we never had a way to teach computers the way that we could teach people. We take it for granted now. You prompt ChatGPT and you're like, oh, well, of course, it's paying attention to what I said. But that was that first breakthrough moment where, suddenly things were not hard-coded. They were not algorithmic for the computer to learn from. And it was actually a true learning process, the way that you might teach a human. So that was probably a first breakthrough moment. And then there was a second, real breakthrough moment for me, which is most people started talking about AI, large language models, after ChatGPT came out in late 2022. But sitting in Brain, we got to see some of those advances as they were developing. And back in 2019 was another breakthrough moment around actually this paper called the T5 paper. You can look it up. I really feel like that paper should be credited a little bit with showing how what the future of language models was going to look like. And so that paper did this amazing experiment where for the first time ever, they trained these large language models of different scales and showed how you could see performance increase. So the very first scaling laws. And they also showed how you can unify different types of tasks and, train them all in the same way into a model. So before, if you wanted your AI to translate something, that was a different task. If you wanted your AI to summarize something, that was a different task. If you wanted your AI to answer questions, that was a different task. And that paper showed how you could put all of those together and end up with a more generally intelligent system. And I think that was the moment many of us felt like AI was finally going to escape the lab. So it had been 10 years before then of just doing these experiments internally. It was still very hard to put AI out in the real world because it didn't quite have that generality that someone could interact with it in whatever way they wanted and get the kind of get that kind of that depth and that understanding that they would look for. So that was probably the second moment.
So interesting, Maithra. Thank you so much. David, he was, I think of the structure of scientific revolutions when I think of you about this paradigm conflict with the way the world was working. When everybody was really into big data analytics in the middle of the 2000s, 2005, 2006, universities start getting departments in that space. And when David was studying via Stanford, he said, this is not the way AI is going to work. And he contrasted and conflicted with his instructors, with the paradigm of instructors. Now he's taken a company from 3 people to over 150 with a completely different form of AI. David, when did it hit you, the intelligence of an AI system in such a way that you were like, whoa?
Yeah. Well, thanks, PJ, and thanks for having me. I think aligned very much with them on those moments. In the T5 paper was special. Computer vision was extremely special. But to go a little off on a tangent of those would be, from my train of thought, I thought that we were going to be able to get AI systems to work fairly well in these large computational palaces of sorts, right? We're in the perfect environment. We were probably going to get AI to work, and that was promising. Almost felt like a guarantee to a certain extent when you looked at some of the scaling laws. We were going to be able to get to something, but in particular, the research being done at Darknet when we were able to get YOLO to run on a bionic chip.
Explain YOLO just
yes.
for a sentence.
Yes. Yeah. YOLO would be I think one of the most formative computer vision object detector models in the world, right? And it stands for you only look once. And it was a technique. There's papers on it. But it had a pretty extreme limit on class count. And a lot of these object detectors still do. And class count is just the number of things it could detect. And I remember specifically the moment with my roommates where we had Darknet, and this is 2017, running on a bionic chip. So it would have been whatever that generation iPhone, right? 20 frames a second, pointing the camera. I still have the video in my in my memories of us pointing the phone across the room and it like horribly detecting things. But the fact that it was detecting things,
right,
and
right.
I remember it like pointing at like a box of Lucky Charms, the cereal, and it like getting it right, and I was like, "Whoa!" Like you're scanning a phone, you're scanning a room,
and it's classifying in a one-shot kind of
exactly,
way.
and like it's looking at the text, it's doing all these things, and then shortly following that, we were working on what later became MOEs, which was we started nesting ResNet 152s into YOLO in Darknet. And all of a sudden, our class counts went from 80 classes to thousands of detectable objects at a high level of accuracy. And that just hadn't been done before. And that was the moment for me where I realized, okay, one, AI is going to happen. Like those self-driving, like this is a real pathway for that. But also, it was encouraging to the extreme where I felt, okay, AI not only is going to happen, but parts of it are going to happen here. Parts of it are going to happen on this thing.
Right, on the edge.
Yes.
So from Palace AI to like the phone.
Yes, and it was like, wow, this is part of the AI story is going to live in people's pocket. Part of it is going to live in places that don't have, a massive data center.
So interesting.
And a lot of the like the dreamy sci-fi books I was reading, right, were like, you have this device you can talk to, or you're on a mission and you're going to talk to an AI.
You can check in with
it. Yeah, like it never really mapped to me. I thought I just didn't understand it enough. I came from a very blue collar family, and like I wouldn't be able to like have connection for this task. Yeah. But it started to feel like, okay, this is actually real. This is going to happen. That was definitely
cool.
the moment, and then everything followed that. But
that's really cool, David. Thank you so much for sharing that. So one of the things we really gathered here, and I appreciate everybody making time to be with us and those who are in Overflow, is to really think about, with the three of you, where do you see AI going? A lot of people talking about it. I tune into TWIML, and it's incredible. But I think the three of you are unique in the sense of you're immersed in your own kind of sense of the fronts of what's coming. And it would just be fun to hear the three of you speak about where do you think it's going? What is the path to sort of a much more general form and maybe even super intelligence? Like, what are the big fronts that intrigue you, Mikhail, first?
Yeah, it's always humbling to try to look forward. I've been wrong so many times, so please, even though I've been living this world for 20 plus years, it's always humbling. But I think two things that seem to be missing are true creative, out of the box thinking for AI. In terms of AI coming up for kind of truly out-of-the-box thinking ideas. And then the other one is kind of...
Meaning that the AI itself having a form of creativity, or how we're using it?
No, that AI have its own creativity.
Okay.
And I'll try to frame that. And the second piece is adaptability and being able to kind of learn in real time and adapt to changing rules of the game. So the first one... our best AI systems today kind of rule within a box in the sense that whether it be the rules of the game of Go, this kind of
Move 37.
classic, exactly,
right.
And then or within the confines of a benchmark, and really creative out of the box thinking that we celebrate from some of the best scientists and artists requires that kind of intuitive leap that we celebrate.
Right.
And, you mentioned Move 37. That's a good example of, a system, an AI system that was able to innovate a creative strategy that people hadn't thought about before, but within the current frame. It's still searching within that frame. And I think the next kind of phase will be, can we devise AI systems that not only search within an existing frame, but devise an entire new frame for us? And kind of the example that is often used is, not only solving the game of Go, but can you have an example, kind of AI that would be able to invent a game like Go that is as beautiful and kind of contained and elegant and worthy of people playing it for centuries.
Right.
And that's the first piece. And the second piece is that adaptability, right? Can we have a system that is not only able to invent a game as beautiful as Go, but is also able to adapt to the fact that rules might change mid-match? Because we live in a world where some things are kind of a given, some of the laws of physics, but we live in a messy world where rules sometimes change over time.
Particularly
right?
human rules, right?
Exactly. Yeah. So I think those two properties, and probably more, but those come to mind right away.
That's fascinating. Thank you so much. Maithra, what do you see? What's intriguing to you? Like, what are you fascinated by about where it's going?
So I'm going to go out there and maybe make some controversial predictions, but I'm excited to see the furthering of specialized agents. That's the controversial one. And then less controversial is reinforcement learning, which I think is how we're going to get there. So firstly, on the specialized agents piece. So actually, the topic that's really central is like AGI, artificial superintelligence, like a real centralization of all of these intelligent capabilities. But I actually think as you raise your standards for what you want AI to accomplish, as you go from being like, oh, I want it to be a chatbot to I really wanted to take actions in the real world, like end-to-end sequence of actions and do those perfectly to like the level of, trust and capability that you would expect from another human, you're going to see some amount of specialization start to happen. So we're going to start equipping our models to be able to carry out various different types of end-to-end tasks, and we're going to develop them precisely for those. And you can already see the beginnings of this a little bit. I think one great example is what Anthropic is doing with Claude Code. Yeah. So, coding tools have been very, very popular across the board. They've been one of the most runaway successful applications of AI. And Claude Code is really this coding agent that will end-to-end do things for you. And you can instruct it to do that. And it operates differently to the general Claude experience. And so I think more and more we're actually going to see some of that. And I think the way we're going to get there is much more use of reinforcement learning. So reinforcement learning, firstly, reinforcement learning is like a method of teaching AIs where you don't give it feedback like every single step, but you try and get it to do a task or like play a game or something and then only give it feedback at the end. Like, oh, you won, you lost, or you did a horrible job with that task, or you did a great job with that task. So it's much closer to how humans learn, but it's also very hard for an AI because it doesn't get much feedback. It only gets feedback at the very end. And so as a result, reinforcement learning has had a very bumpy history with AI. I think actually when OpenAI was first founded, they got very excited about reinforcement learning and they invested a lot of resources, but we were just too early, so we didn't see it work out in the ways that we might have hoped. But now with these large language models acting as this powerful foundation with these base capabilities having gotten better and better, I think we're going to be able to leverage reinforcement learning much more effectively. And we're going to leverage those also to build out these powerful specialized agents.
Thank you so much, Maithra. David, how about you? Where do you see it going?
I agree on the specialized front, absolutely. I think the creativity piece you mentioned is interesting and needs to happen. Not sure how we make that happen, but what we look at a lot internally as like a North Star is a civilization model. It's a term we've made and we stick to it. And a civilization model is really this idea of where have we seen superintelligence practiced. There is no individual representation of superintelligence that I'm aware of. And the only example of superintelligent outcomes we have is a collective of contextual brilliance, right?
So like in aggregate.
Yes. So an example of superintelligence to me would be, I was in Austin, Texas this morning, right? So I got on a plane and I made it here and then got in to do this panel. And all of the things required along that trip.
Thousands.
Yes, super intelligent components, not to mention the digital technology on the aircraft, the pilots, the crew, everything.
You mean when combined?
Yes.
In some sense?
Yes, absolutely. So
it got you here.
Yeah, but really when we're talking about AI outcomes, we are talking about like the outcome. We're not talking about like every layer step or every potential contributing factor. So when we think of a civilization model, it's to us, what is the best representation of intelligence that could be general, right? In our opinion, would be it's going to be a highly contextual fabric of models. And by contextual, I mean experts at different things. And a really simple, crude example is like if you have a medical problem, you don't text your brother unless your brother's a doctor, right? You would text a doctor or call your doctor. Similarly, if you're building a home, you would talk to an architect or an engineer. You wouldn't, message a software engineer.
So knowing which model to go to.
Yeah, and there's a lot of conversation about like open routing solving this, but I think that's missing a big component of how civilization works. Is it's not a for loop. It's the fabric of the model itself knows and has its own rules, and like civilization has its own highways. It has its own buildings, and like I think that's really interesting. I think that we'll see probably some really incredible breakthroughs as we get closer to that model. And I think the second thing is, I think that as we see models compress in size, so intelligence compresses. It's been true forever. So I would view models as scaffolding, and say like we look at these models that keep getting larger. The scaffolding required to discover something is always far greater than the scaffolding required to learn something. So an example would be to discover a law in physics requires an incredible mental scaffolding. To learn a law in physics does not.
Okay.
So we need to separate categories of AI around that and say like what are we doing to discover, and then what are we doing to practice, leverage, and superintelligence is going to be a mixture of both. But I think that piece specifically, we're going to see manifolds compress, and we're going to see models get smaller that have learned off of these large scaffolding.
It's so interesting, because with the 9 minutes we have left, I would love to first of all see if either of you have any reflections based on what each of you has said. But what I hear you saying, and for the audience, there's been this progression from multiple models being combined, a mixture of experts, to a larger sum of them, like a composition of experts. This is MOE, COE. David's like now talking about the idea of many millions models, billions,
yeah,
of working together like a multi-agent system. And that in and of itself becomes super intelligent, like civilization.
I would say civilization is super intelligent.
Is like that, right? That's your model for what super intelligence is.
I don't think we are. I think, but as a whole, we've done pretty super intelligent things.
Yeah. That's fascinating to think like that's the model for AI. That's interesting.
It could be wrong.
No. It's really. Maitra, Mikhail, anything else to reflect on based on your dialogue?
So maybe one thing actually David mentioned this too, on the point of the scaffolding between discovering like a law of physics versus learning the law of physics. And I think, Mikhail, that's actually very similar to what you were saying, which is, can you invent this game of Go? And I'm feeling pretty optimistic that we'll see something get there. I think the first versions will be maybe the low-hanging fruit of what humans have missed by AIs just being able to pull in some of that human knowledge, reason about it the way that a human would, and pull out, these connecting insights. In fact, I think now there are multiple places that are very excited about applying AI in this way to various different types of scientific discovery. So while that's not quite building out the full law of physics or maybe the full game of Go, I think we're going to, I think that's like a first step forwards. And then, maybe later on, like this year, we had a lot of excitement because AI managed to solve these IMO, like the International Math Olympiad, and get these like gold medals. So I think the future would be, could it come up with a problem that's like IMO level instead of just solving the exam and doing well. And I'm feeling pretty optimistic that we'll see progress on that, at least in places where there's information to reason through and discover, places where the scaffolding you're working within, at least if you're, for example, creating a problem, there is sort of something there. And then stuff that's truly open-ended, that might be the thing where you're thinking about a space where there's lots of AIs collaborating with each other to go beyond. But I think we'll see a lot of progress on that in the next couple of years, and it should be really exciting.
So interesting. Mikhail, rejoinder thoughts?
No, I just find it, I think maybe one takeaway is that was common across here is, for a lot of us, we're just incredibly surprised that some of this stuff has come as fast as it has, in the sense that a lot of us were in the trenches. Your story about YOLO suddenly working, I think, I'm still in this kind of space where, trying to catch up to the fact that in my lifetime I didn't expect some of these, kind of leaps that we've seen, but then also with humility in the sense that there's some big challenges ahead of us. So it's these two conflicting ideas of I can't believe this is working as well as it has, but they're still being grounded in the fact that there's still for a lot of challenges ahead of us, and so it was reassuring to hear. I think some of the commonalities there.
Yeah, it's definitely moving fast. With the 5 minutes we have left, what we thought would be fun would be, given where you see it going, given where you've seen it go, as fast as it's moving, and cut through all the debates of like sentience and consciousness and is AI just math, right? Just to hear your personal thoughts of like, what is the difference between machine thought and human thought, and why does it give you like a positive view of the future? And why don't we just come down, David, Maithra, then Mikhail. We have 5 minutes.
Yeah. I think what makes it math and not sentience is I think people that are building it have more appreciation for that reality, one, because we work on it and we know changing core components drastically change how these systems work. I think one of the things we're missing that I fundamentally believe is we're missing inspiration. And there is no evidence that models have any kind of inspiration. And like I'm talking from a philosophical sense.
Right.
And I think that that's going to be the greatest barrier to see things really create. Now people can create based on a corpus of knowledge, and an AI can map parallels there. But to see something, I don't know. I just don't see a medium for inspiration to enter.
Would it be right to say that creativity can be trained a little bit, but that's not the same as human inspiration?
Of course it can be. I think it absolutely can be trained. I mean, you think of like Josef Albers, one of the greatest artists in the world, who created a school of really thinking in regards to contemporary art, was legitimately a school of contemporary art, and it led to all of these great following artists. That you'll see at the Met, like at some of the great, like the Guggenheim will have all their works. Yeah. So like why is that? Well, I think they were taught, but I think there's inspiration tied to that. I think that's the biggest challenge I see. I don't think AI is sentient at all.
And the human inspiration is
it has no evidence of human inspiration, other than the fact that we made it.
Fantastic.
AI hasn't made it. When AI makes a human, I'll be much more interested.
Maithra, I'm so interested in your thoughts. I've always wanted to ask you this.
Oh, so then I'll say something controversial. Actually, it's gonna be less controversial when I dig into it. But I'll say that actually, I think AI thought and human thought might be quite similar. And even today, people are starting to see, for example, ChatGPT and other of these like general AI tools being used much more by their kids. There are like lots of toys and stuff that are incorporating all of this, turning this into something like very interactive for like their kids to like play with and learn about, it's a bit of a scary thought, but it's happening already like across the world. Like the most recent article I read, like in South Korea, I think there was an effort to integrate ChatGPT in with these like dolls that they were giving to a lot of like elderly people and things as like a kind of companion. So in that sense, I feel like it's similar. But I think what's different, and I think what David really meant by like the inspiration piece, is human experience is very different to AI. Like AI does not experience the world like a life or whatever, like the way people do. And so I think it's less about thought. I think it's much more about experience. And I think that's also why it's really important to make sure, we're always thoughtful about like having humans in the loop, or thoughtful about humans setting the priorities for what is important for like AI. And then it can like act in that in that universe and with that context in mind.
So interesting. Mikhail?
Yeah, this has got me thinking in terms of, I think humans, we've, in some sense, for a long time defined ourselves by intelligence, right? So if you think Homo sapiens is like, literally kind of wise man or wise human, right?
That's why this one's so different, right?
So, in a world where we have machines that are able to, plan, reason, and even create, what does that mean for us? And to me, I'm a bit of an amateur painter. So AI guy, but like to like relax if I'm doing a little oil painting. And so I'll make a kind of a art analogy in the sense that, for centuries, painters, the craft was really about, diligently capturing light and shadow, right? And then the camera came along, and which was able to depict reality within milliseconds. And you'd think that, like, painters would have despaired, but instead that kind of unleashed, their ability. You think about Impressionism, Cubism, Expressionism, and really it was when you've made kind of diligently capturing like the rigorous detail of reality a commodity, expression became priceless. So I think that maybe AI may be this kind of camera moment for cognition. So thinking about maybe redefining, it's not about necessarily intelligence strictly, and maybe humanity could be kind of taking a bit of a kind of reframing in terms of maybe it's about not being the calculators and more kind of the kind of conductors of a kind of orchestra of being able to curate intelligence to some kind of new humane kind of goal and being able to direct those goals. And I think there's a lot of questions about that. Who, now that would be a commodity and accessible, in whose hands is that? There's a lot of questions, but that's kind of where my mind goes with that.
I'd like to think from yours that maybe we'll think better. And from Maitra, from yours, that we'll appreciate human experience more and more. And that maybe we'll be more inspired, right? And so, this is really the beginning of forever. And so I think sometimes it'd be fun to look back on this someday, right? And see where we've gone from here. And I just want to thank you all three so much. At SCSP, we have the highest respect for you. Thank you so much for traveling. Thank you for everything you've done to advance the art. Ladies and gentlemen, please welcome my panel and thank them.
Thank you.
Thank you.
Thank you to our panelists. Our next session will